Hi guys, a real quick video on the fundamental counting principle. Just so we'll go through this real quick. We're gonna make some sandwiches, brown, white bread, and you have ham, tuna, salami, or turkey. So first option is brown or white bread, and then we're gonna go with ham, tuna, salami, turkey. So that's a different, so I'll put TU for turkey. Oh no, tuna is also, so that's turkey. Ham, tuna, salami, turkey. Okay, so that's that. Next question says, if one event can be, so we want to figure out how many different ways can this be done. Okay, so if you count the ends here, it's 8. And you must have noticed yesterday also that there is kind of a pattern here when you have a tree diagram. If you have 2 branches here and then 4 for each here, like this, so that's basically what we're doing here. How many terminal branches do you have? It's 8. And how do you get 8 from 2 and 4? You probably guess it, you multiply them. So in general, if you have m ways to do something, and n ways to do something else, you have m times n ways to do the 2 things. Okay, so let's talk about flipping a coin. Remember we said let's flip a coin 3 times. Well, there's 2 ways to do the first flip, 2 ways to do the second flip, 2 ways to do the third flip. 2 times 2 times 2 is 8. Okay, so that's why we would have 8 branches there. So that's the fundamental counting principle. In the situation above, how many options are there if you can also add a choice of mayo or mustard or neither? So be careful on this. That's 3 options here. Okay. So that means we already had 8 options for our sandwiches above, and we have 3 different options. Are we going to add mustard to each of these? So if we go back up here, each of these here, so let's just look at this one here, white and ham. Am I going to add mustard? Am I going to add mayo? Or am I going to add neither? Okay, and you might also say if you add both, you could have 4 options there, but let's just say we can't add both. We can add mayo, mustard, or neither. So that means there's 3 options per sandwich, and that's times 3. So you just keep multiplying. Here you want to flip a coin and then roll a die. So flip a coin, there's 2 options, head or tail. Results for rolling a die, there's 6 different options for that. So 2 times 6 is 12. You could have a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6. And then you can do the same thing with the tail, a tail and a 1 all the way down. So that's the fundamental counting principle. Let's keep going with the note here. What happens if you roll 2 die? Okay, so we want to list that below, the different ways to do that. Okay, and one way we do with dice, 1, 2, 3, 4, 5, 6, is you can make a table like this sometimes. Okay, so sometimes, oops, it's better to draw a tree, but this tree would be huge, right? 6 by 6, 36 different branches. So instead of doing that, you can make a grid. And you know what? Let me do this here. Let's do we'll go 7 by 7. We'll see why in a second. 7 by 7 grid. And it'd be nice if it worked. Hold on a second here. Let's insert a 7 by 7 table and go. And no. So that didn't work. Hold on. So it's a 7 by 7 table here. 6 by 6 or 7 by 7. So here we have the first row 1, 2, 3, 4, 5, and 6. And then we have the second row here 1, 2, 3, 4, 5, 6. And if we're going to look at this table here, different ways you would set this up. One is if the order matters for the rolls, and another one is for sums. So let's just do it this way where the sum matters. So if you roll a 1 and a 1, your total will be a 2. A 1 and a 2, your total will be 3. And then you fill this in this way. Okay, so a 1 and a 6, that's a 6. You have a total of 7. And you're going to notice some really nice patterns here. Okay, so if you roll a 1 on the first roll, you can have all these different numbers. And then when you fill this in, it's really kind of neat. You notice a couple things. One is that kind of shift everything down. But the other thing is if you look this way, there's all the 4s. There are all the 5s. 4 and 1. It's kind of cool. 6s go here. 7s go here diagonally. You got an 8 here, an 8 here, an 8 here, an 8 here. You just jump around. 8, 9, 10, 11, 9, 10. There's a 9. Only the 1, 12, 10, 9. Okay, so you look at that, and that are all the different options for rolling the dice. So we'll be looking at that. Oh, what do you know? There are my tables that I wanted earlier. So let's delete these guys. Delete. And great. Okay, so this is what happens when you rush a video, eh? Hold on. So we listed everything on that other page, and then we'll get to those questions later. Like, I'm sure we'll play around with them. Here's something neat. How many 2-letter words can be made So any two-letter word. So think about that. So two-letter words. A word just means, when we talk about words in quotation marks, we mean two letters together. So for example, this is a word, ZZ, or QL, that's a word, okay? Even though it's not a real word that we use. So the question is, how many two-letter words can be made? So how many letters, options are there for the first letter? 26, because there's 26 letters, and then times 26 for the second letter. How many two-letter words can be made if no letter can be repeated? Well, you have 26 options for the first letter, and then 25 options for the second letter. So sometimes here, that's the multiply symbol, but sometimes when we do this, we just put a dot there to kind of quick it up. Okay, so 26 and 26. How about this? Start with a vowel and end with a consonant. Well, A, E, I, O, U are the vowels. Are we going to include Y? Let's not, okay? Let's start just with these ones here for now, okay? 5, and that would mean that there are 21 consonants. Okay, so 5 options for your first letter, 21. So you're going to multiply those two and figure out what that is. Now, if you threw a Y in there, this would be a really good question. If you threw a Y in there as a vowel, it should be 6 and 20. But if you said to yourself, well, Y can be both, what would happen then? Well, you'd have 6 options at the first, and then you would also have just not these, right? So not 5. So you would have 6 times 21 options total. Okay, don't worry about that too much. It's just kind of the wording there. How many words start with a consonant and a vowel? So again, whatever you assumed a consonant and vowel is, you do things backwards here, you get the same number. Okay, it's kind of neat. How many two-letter words have a vowel and a consonant? So how would this work? This is a good question. Okay, well, there's two different scenarios. One is when you start with a vowel, and one is when you start with a consonant. So what you can do here is go 5 times 21, and then what you'll do is add. So these start with vowel, start consonant, and then you're going to add them together. Figure out what each of those are and add them together. Okay, that's it. Little start there to section 2.2. Take care.